Okay, thank you, folks. We'll just give it a maybe 30 more seconds. This is really exciting. This is the third webinar in the annual SENTRY webinar series. So we've been through, webinar one was using SENTRY primarily for municipal or industrial plants, wastewater plants, to profile incoming wastewater, detecting toxicity, profiling the impact of heavy rain events on treatment performance. The second webinar last week was mostly with some of our European clients, looking at aeration optimization, how the data can be used as a feed-forward signal to understand organic load and aeration control. And this week, this is my one. I get to coordinate this one. This is very exciting. This is anaerobic digestion, and this week we have. I'll do a quick introduction, and then we're gonna send it over to Chris Bush, who's the president of Catalyst Agri Innovations, working with, what's the name of the dairy in Abbotsford, Chris?
Bakerview Eco Dairy.
Eco Dairy. Okay, so Chris has a pilot scale system that's quite remarkable in terms of the number of reactors and the attention to detail that can be in terms of data that's coming from those reactors. So Chris will speak to that. And then Peter from Central Marin Sanitation Authority in California. We've been working with CMSA and Peter over the last 2 years, I believe, Peter?
Yep, 2 years.
And we've gone all the ways from pilot scale testing using our data in pilot scale skid type systems and looking at co-digestion of organic waste streams, all the way now through to monitoring those fog and those co-digestion, that blending of offsite organics into full-scale systems. Okay, so Alex, is it good to go? Should I move in? Oh, you're muted.
Mute. Okay. It's only been a year and I still make that mistake every day. All right. Just a quick overview of, if you have any questions, you can feel free. So we'll move through all the presentation sides of things. If you do have any questions, you can feel free to type them in the chat. You can also introduce yourself in the chat because we'd love to get to know our audience a little bit more. Or there's also a Q&A function. So I'll be keeping an eye on both of those things, myself and Juliana, so we can answer your questions at the end of the webinar. You can also just stick your hand up and we can unmute you and you can ask your question yourself. All right.
All right.
So
thank you, Alex. Okay, so the first 10 minutes here of this call, I'll just do a super high level intro to what SENTRY is, get everyone on the same page, and we'll go from there. Okay, so what is SENTRY? So my personal background, I'm a microbiologist, and it's become very clear to me that biology is the key to wastewater treatment, whether it's municipal aerobic wastewater treatment, whether it's high strength industrial anaerobic digestion. It's biomass, an active biomass that's doing all of this work. And the tools that we currently have to understand how these biological treatment systems are performing, these tools don't work very well in wastewater environments. If you take a light-based sensor and it functions by sending a light beam into wastewater, refracting off those compounds, and you have to get a really nice signal through and through that glass slide, it's just not going to work well very long. You might get a good signal for a day, maybe a few days, but invariably you have operators that then have to go and maintain those sensors, clean them every other day, certainly every week. And sensor drift is just always a problem that everyone complains about. So understanding or trying to figure out, can we get signals from these biological systems that can be robust, can be reliable, can generate data that we can make decisions on, is something that we're passionate about. As a team, we're passionate about the environment, and the driving factor is that we want our clients to be able to make smart decisions in terms of treating water or treating wastewater. So the presentation today, we're going to focus on anaerobic digestion. How can operators of ADs protect the performance of their bioreactors? We might look at, can we optimize how much carbon is being added to these digesters? Because that's the key driver. If you can optimize the feedstock, the loading, the organic loading into these digesters, well, that's a direct link to maximizing your biogas production. And then, you know, can we set alarms in situ from the biomass that will notify us in real time when things are going wrong for our digester? Have we taken an offsite load of some organic stream that wasn't appropriate? Was it twice the organic load that we're normally used to? Was it half the organic load? Was there something else in that load that was acutely toxic to the biomass that just sent things going sideways? So can we use the data to set those alarms and notify our operators in real time? Okay, so what is SENTRY? So the core of SENTRY technology, it goes back to the concept of microbial fuel cells. So what we do is we take, in our case, we take two conductive surfaces. We apply a very small voltage across those two surfaces. There's biomass already growing on these surfaces, and this biomass is mixed culture. It's a mixed culture of everything that's in your wastewater reactor already. And what the biomass does when it's growing on these surfaces is it does the same as every other microbe in terms of consuming whatever organic carbon is available to them. So it's consuming organic carbon, and the only thing it does different is it donates its electrons when it's eating that food. It donates its electrons to these conductive surfaces, and we simply measure the flow of electrons from the biofilm in the reactor. So in a very real sense, what we've developed is almost analogous to a heart rate monitor for the biofilm or the biomass that's driving your performance. And you can look at it two ways. You can look at it as this is a measure of how much food is being consumed, so carbon consumption rate, or you can look at it as just a measure of biomass health and whether my biomass is in a good zone of activity or whether we're pushing it too hard, there's too much food in the system, or whether there's not enough food in the system. But in a very real sense, we're taking biological activity and converting it into a digital signal for operators to see and visualize it and use. In terms of the core technology, it's really simple, or we try to make it as simple as possible. So we provide our clients an EMA 4X rated outdoor panel, and then the sensors are connected directly to this panel. The sensors, there's no moving parts. They're not designed to be fickle or complicated. You simply take the sensor. In this case, the sensor is going into an aerobic outdoor basin. So you can see the sensor is just attached to the end of a PVC pipe and just lowered into the wastewater stream. For anaerobic digestion applications, the sensors tend to be hard piped or tapped into a recirculation line, very standard 1.5-inch NPT fitting. So you're just screwing the sensors into a recirculation line. Or a lot of the time with anaerobic digestion clients, we put our sensors at the effluent line of those digesters, and that tends to be a very good location as well. So this is what the operator would typically see, or this is the experience. You take the sensor, you place it in the wastewater stream. So this, for example, would be in a recirculation line. The wastewater flows past the sensor. The biomass is growing on this surface and sending that information directly to a visual interface, so an online dashboard that you can see. And in a very, very simple way, and this is the most simple way that the information is used, we would set high and low alarms on the dashboard. When there is more food in the wastewater than normal, that would trigger a high-end alarm for the operator. So the operator is now getting notified, okay, something has changed in my wastewater reactor, in my anaerobic digester in this case. There's now more food than normal. So what have I done in the last few hours that has caused that to happen? Or on the low end, the operator might get notified as to a low-end alarm. And that would be typically one of two things. Either there's something acutely toxic in this wastewater right now, or this wastewater has been diluted by some way. Maybe I've reduced organic loading. Maybe in some cases, heavy rain, storm infiltration is getting into my process. But that is the most basic way. So it's an always on, low maintenance platform that's notifying the operators and letting them see in real time what's actually happening in their reactors.
Patrick, how about we take a poll
Good,
now?
thank you, Selena. Yeah, perfect.
Okay.
Okay, so we're going to do the first poll here, folks. Now the panelists can't actually answer this one. Sorry, Chris. Sorry, Peter. But everyone else can. So the first poll, what current tools or technology do you currently use when you're monitoring the performance of your AD system? So are you using manual phosphatic sample analysis? Are you doing real-time TOC? Are you measuring biogas production or biogas flow? or are you measuring VFA analysis? So we just want to get a feel for the people that are here that are listening in. What is it that you're actually using yourself currently? Just to get a feel for, what people are currently using. Okay, Selena, you tell me when
We'll give people 5 more seconds.
5 more seconds. All right, folks. I think you can click more than one answer as well, so don't feel like you can only push one.
Okay, now I end the poll. Let's see the result.
Okay, so yeah, perfect. That makes a lot of sense. Okay, so biogas is the main one, and that makes sense. If you're looking to measure the performance of your system, looking at biogas production certainly makes a lot of sense. VFA analysis coming in second, that makes sense as well. And hopefully we can, let's say, look to help people replace some of that VFA analysis maybe, or complement it certainly with more in situ data. Okay, thank you, Selena. Okay, so this is just a map of everywhere in the treatment process where we typically put SENTRY sensors. I'm not going to dwell on this. Today we're looking at co-digestion, anaerobic digestion of wastewater streams. So I'll leave that here just to say we do typically also work, we place sensors in primary clarifiers, really profiling everything that's coming into a wastewater treatment plant, feed forward signals for aeration control, and also we love biological BNR type processes, understanding where carbon is, carbon isn't. That's something that we're really good at. Okay. So let's go on to our presenters for today. So we're going to talk about anaerobic digestion and renewable biogas production. And the first case study that we're going to speak to, I'm going to introduce Chris. And Chris works with us at the Bakerview Eco Dairy in British Columbia. Chris, do you want to maybe take it away, and let's just start with who you are and what you're doing with SENTRY, or what you're doing at the Eco Dairy.
Yeah, thank you. Appreciate the opportunity. So back in 2010, I built the very first on-farm biogas plant at all in British Columbia. And I came out of telecom. I stumbled on the idea of anaerobic digestion, page 63, a little sidebar story at the back of Popular Science. And I was doing mobile asset management and mobile information management. I really didn't understand then that I was moving into a new realm of information sciences. And only recently we're getting there. I completely trusted the science. Germany had 7,500 plants. There were thousands of these things done industrially. I thought these guys really understand all the science. This is just a business case problem. That's why we don't have more of them in Canada. And I set to work and ended up after a couple of years with $1 million in education from that. We've had the opportunity recently, I built the very first on-farm biogas plant. A fellow named Bill Vanderkoy built the second on-farm biogas plant at the Eco Dairy. And it was in itself a study to see if you could economically do on-farm biogas at very small scale. So the reactor's built for 60 cows, and resoundingly the answer came back, no, you can't. There's no economics for it. It costs you somewhere between 18 and 32 cents plus a lot of work to make something you can buy for 7 cents. Okay. Right? It's not a good case. And it was shut down a number of years ago. That picture, the previous picture, is James and I standing inside of a $5 million anaerobic digester pilot plant that's specifically set up with dual chains to do analysis of different technologies so that you're working against a real-time control. You can isolate to single variables. And what we are doing there, we have a project called Biodigital Convergence, where we are training AI to run AD. And the tools that SENTRY gives us, it's a real-time, Patrick, correct me, I used to call it a lie detector because it's reading all these things from your bugs. It's more of a Fitbit, and it tells us how the bugs are feeling about things. What we have been able to do with the SENTRY tool in this biodigital convergence, we have a sensor that tells us exactly what is going into the reactors: nitrogen, potassium, phosphorus, ammonia. Ammonia is the specific trigger we're chasing. We've got the SENTRY that tells us how our microbes feel about what we're doing. We've got a gas chromatograph. We've got a machine that tells us exactly what is in the gas. We have another machine telling us how much gas is being made. We have another sensor pulling all sorts of environmental data just from the ambient, all the things around us. And then another company called AgriLize is taking all of that data and putting it into a single time-aligned stamp. And while we're gathering all that information, University of British Columbia, the Hallam lab is mapping the metagenome of the microbial community. So what bugs are working and who's moving, what's the community movement. We're intentionally crash testing the digesters like they crash test cars to see what's going on. And we've just sponsored a data analyst through MyTax with the university that's hunting for signals. Because, you know, on-farm biogas is really run reactively. You know, the poll that you just did, it's, you know, everybody watches how much gas they're making, right? You know, people do FOSTAC, but that, you know, usually we'll do a FOSTAC after your gas production goes down that tells you, oh yeah, there's a problem.
There is a problem now, and we've possibly had a problem for the last 2 days. So if we could get more kind of predictive data up front to say, okay, something's changing.
Yeah.
Let's be aware of that right now, and let's try and make this change before we have that dramatic impact on our biogas production.
Yeah, so that little window, for example, funny thing, that ends June 17th, that little downward stroke, right? We had a circuit breaker go that controls the mixing. So our mixing went off for a little bit, and that popped up on our screen. Said, oh, something's wrong. We went and found that mixer was off.
Fantastic. Right? Okay.
You
So
know,
could you maybe just speak to that? So these sensors are installed in those pilot systems. Could you maybe speak to the testing or the just high level, what's being done?
Yeah. So these are 400-liter batch reactors that you'll see a couple of them noted. We're testing different stirring mechanisms. So everything is identical except one, we're taking material from the bottom of the tank and physically pumping it to the top to stir it. The other one, we're taking the produced gas from the top and bubbling it in the bottom to see the differences in what it makes. And it's interesting, you know, watching those movements because those spikes are stirring events. Yes, right, and we can see what's going on there. And interestingly too, you know, other learning, because there's so much information available now, we can see it in real time. That red window at the beginning of the slide you see, we were doing batches, and we originally got a whole bunch of fresh feedstock at the beginning of the whole program. It had aged pretty dramatically, and when we did that feeding event there, that small window, we saw, oh, we didn't get any impact because the aging of our feedstock had caused the gas not to go well. Our next feeding cycle, you can see we went out and got all fresh again. Fantastic. Right. So, you know, it tells us, you know, and we could watch that trending downward as that feedstock sat outside, not mixed, not heated, separate, just sitting there. What's the impact of fresh versus aged?
Fantastic. Right? Exactly. And that's a common experience that people who are receiving off-site waste will have to deal with because they're not in control of that waste stream. So having an ability to see actually how it's impacting your process, I imagine, would be massively valuable.
Yeah, for sure. And our facility, we're specifically doing manure only, no off-farm materials. But if you are doing off-farm materials, you get some number of trucks coming in every day, and you will have some listing of what it's supposed to be, right? And hope that it's consistent. But with this system, you know, Patrick shared a story about a plant that I think every 3 weeks, say they have some event, and they were able, the SENTRY showed that event as it was occurring. So they said, okay, what's happening? And they went and they found it, and the truck was doing, every 3 weeks, it did some other place before it came there and had a residue that impacted the digester. You know, that could save a company thousands, maybe tens of thousands of dollars, a discovery like that. And the cost of SENTRY, I would bet for many, it'd be paid back in hours, maybe, right? Especially hours of an event, it could be paid back in minutes.
Fantastic. So I've just put up the next slide there, Chris, in terms of the data, just because your group does tend to do some of the most detailed analysis of digesters that we've ever seen. So we've just taken 2 of the recent data sets. Could you maybe speak to this in terms of just what you're seeing? So what we're showing here in the 2 graphs is the orange line in both cases is the biogas production. And these are the 2 reactors basically in parallel with the 2 SENTRY signals. So CCR stands for carbon consumption rate. That's what we're measuring on the SENTRY signal. So just high level, what people will see is, oh, it looks like biogas production and this activity trend really well. But for us, and we've highlighted it on the bottom graph, it's when they diverge. That's when it's really interesting to us, because then you know, okay, there's potentially an issue here because the microbial activity is going up, but the biogas production is going down. That's a real flag for an operator. Could you maybe just speak to the data, what it meant to you, and this type of analysis that you do?
Yeah, so we're really torture testing this. We're in the process of training AI to run anaerobic digestion, right? So we're doing everything we can to get the most, violent isn't quite the right word, but the biggest signal markers. So we're doing batch feeding, we're controlling a whole bunch of things. Those big spikes you see are around feeding events, right? And we use this to tell us when they need to be fed. And like I said, you can see that different things as the feedstock ages, right? This is a very small sampling that we're using to get started with a much larger project. At this facility, we've got 0.5 liter, 1 liter, 20 liter, 400 liter, 4,500 liter, and 85,000 liter reactors. And we're following these microbial shifts to see, so much information. Again, this is telling us that the SENTRY tells us in real time that there are events. And then we can take all of the other data that's around it and understand what that means. Because when we can see these trends starting to happen, we can intervene. We want to have those lines all to be very flat if we can, right? And
Yes.
get them to the highest possible level.
Yes.
Right.
And in a weird way, you could do that here. Just as you said it, you're optimizing those batch feeding cycles. You could shorten those periods where clearly the signal is low and clearly there's not a lot of food, and maintain those higher levels of activity. And that's where you have your maximized biogas production and stable microbial performance.
Yeah, our larger reactors, when we get to the 4,500 liter in that earlier picture, there's actually 6 reactors there in 2 chains, right? We're able to see the timing and all sorts of things. And we bought 18 of these SENTRYs to put all over this place and to see the timing and to see all that. In reality, a commercial digester is going to be bleed and feed, where you'll be semi-continuously feeding and then driving off some material, right? So we won't have these big spikes, but we really want to amplify these signals right now so we can understand, because they'll be harder to see in that continuous feed system. But again, this is all stuff that was simply not possible without a bioelectric sensor, without a sensor like this that's in place right now. And the fact that they're so cost effective means you can buy a lot of them. You can get lots of information, right?
Fantastic.
And yeah, I absolutely love the tool, and we're excited about what this means, because we really do intend to revolutionize on-farm biogas with community scale facilities. And the more information points you have, the better job you can be. We need to make these more reliable, right? Because a biological crash, if you're just chasing your tail with FOSTAC, something could have happened, 2 weeks, 3 weeks before you really see it. And by then it's really too late to intervene.
Yeah, exactly. Okay, Chris, thank you very much. Thank you very much. I'll just summarize briefly here in terms of just some of those outcomes. And then we're going to go over to Peter. And it's actually very exciting for Peter, because Peter's done a similar thing to you in terms of starting at the pilot scale. So I think that work will certainly resonate. But just to summarize some of the things that we were doing and continue to do with Chris, detecting and quantifying the impact of those changing organic loads, correlating that signal to biogas production, and really trying to flag those periods when they diverge, because that's when you know something bad is happening in your reactor. Using those SOP guides and using the SOP guide to flag those events. So if there's an alarm from SENTRY, going back to the SOP and trying to figure out, okay, well, what's actually the root cause of that? And just optimizing, generally speaking, optimizing the loading to the digester and maximizing performance.
I'll just add, Patrick said about something bad happening. We are also watching for something good happening with all that information, trying to figure out how to make that good thing happen more often. Yes. Right. And again, these are just tools you don't otherwise have. If you don't have real time, you miss it, and you can only theorize what might have gone on. We're going to get all that information. Thank you to SENTRY.
Thank you, Chris. Love it. Okay. Next up, Peter. I'll do a quick introduction, Peter, maybe, if that's okay, and then we can just go back and forth on slides. So we got connected to Central Marin 2 years ago, I think, Chris. Peter, it's been a while now. And Central Marin really are one of the leaders, I would suggest, in terms of municipal thinking forward-looking municipalities in terms of the wastewater treatment side and looking at it as a cycle, and looking to opportunities where either renewable energy can be generated, and certainly where, you know, the plant can be more efficient or effective. So in terms of co-digestion and leveraging those on-site digesters, leveraging those assets and trying to generate as much biogas as is possible or as is realistic from those assets is something that Central Marin has kind of been leading on in the US. We connected with Central Marin 2 years ago. They communicated to us that, yes, you know what, we're looking at taking offsite restaurant waste, fats, oils, and greases, that type of restaurant waste. We're looking to blend that into our municipal digesters. And we have a pilot system that we're testing coming up with Black & Veatch, and we're going to look at the impact of different organic loads into these pilot systems to try and identify the best blend for us for our digesters. But the problem is you want to have the right blend, but you also want to make sure you're not pushing it too hard. And certainly you want to make sure that you're not putting something into that digester that's going to upset your biomass. So it was with that general problem statement that we got connected and we started talking, and we're now, you know, we're through our pilot scale testing, and we're now installed in the full scale digesters. Do you want to maybe just speak, Peter, as to, you know, your facility, what you're doing, where the sensors are?
Yeah, sure, absolutely. Yeah, so I'm Peter Kistenmacher. I'm the technical services manager here. We are a municipality. We service about 100,000 population equivalents, about 10 minutes north of the Golden Gate Bridge in San Francisco. You can see our plant there on the bottom right, about 10 MGD dry weather flow, you know, mostly residential, not a lot of industrial. And we have 2 anaerobic digesters that where that green arrow is pointing, with membrane covers, about 1 million gallons each. And that's it. You know, we've been happily operating that way for many, many years, since 1985. About 10 years ago or so, we started taking small quantities of source separated food waste. You can see the process there on the top left. That happens at a solid waste transfer station down the road, where they're taking, you know, restaurant waste, grocery store waste and the like, and doing some minimal pre-processing, putting it in a truck, bringing it over to our site, and then we inject it in the digester together with our wastewater solids. So we have been doing that, you know, like I said, almost 10 years. Things were going great. You know, we have East Bay Mud, if you've heard of them, is a very large utility just down the road from us that sort of pioneered a lot of this on a much larger scale. And so we were, you know, following them onto the 10 MGD type scale, and things were great. We're doing about 20 to 30% of our volatile solids loading in the digester on a mass basis was coming from these external feedstocks, and the rest from wastewater. And so what we want to do is we realized we had a lot of extra capacity in the digester, and because the population isn't growing fast here, and we wanted to put in more external feedstocks, including, you know, fats, oils, and greases, and sort of these engineered food waste slurries that came from other places in the Bay Area. But some of the you know, consulting community and like cautioned us that other agencies had run into problems when they pushed that organic loading up to, say, beyond 30% from external feedstocks. And, you know, only having 2 digesters, we really cannot afford a problem, because there's no redundancy for us. And by the way, we do monetize our biogas. We're completely energy neutral, and we do export, you know, a small percentage to the grid and get paid for that. So and we're very high power cost out here in California. So, you know, loss of a digester, loss of biogas production is a significant financial hit for us, as well as we don't get the tipping fees that we get from the food waste and fog that we receive. So we're most important to us is minimizing digester disruptions. And then of secondary importance is kind of optimizing how the digesters work so we make the most gas and make the most revenue. So we decided to do a pilot together with Black and Beach and actually Corolla engineers and a few other organizations, and we said, well, that's a great opportunity to use this new sensor in the pilot and see how it overlays with all this large amount of data that we're collecting. So what you see in this chart here on the slide speaks to what we feel is potentially the predictive power of this technology. And you have a yellow line and a blue line, going back basically, what is that, 2 weeks or something?
Yeah, this is like 2 weeks before.
Yeah, so you have a very regular and predictable pattern. And by the way, we fed these pilots from I think it was 8 o'clock to 2 o'clock. So we fed it over a shortened period of time. And these little humps basically correlated with sort of when the food came into the digester each day and, activity picked up and then stuff was consumed and, evening hours leveled back out. But most important to us was it was predictable and repeatable. And then what happened in this May 9-10 timeframe is the pattern, was obviously interrupted, as you can see from the chart. Just no more. It didn't come back down. It was completely different. And at that point, all of our traditional digester health metrics, volatile acids and pH and the like, they were just still showing
normal.
Everything perfect, normal. So, and what we had been doing all throughout this time, though, is trying to put more organic loading in the digester. And just due to the nuances of doing a pilot like this, we have limited control over what exactly we're feeding it. And some of these fog trucks, one day they might have been bringing us, 2% solids. The next day, some of the stuff had like 18% solids. So it was a huge sort of, it's like eating hamburgers one day, 6 hamburgers versus a salad the next type of thing. So, and we, just because of the nature of the sampling and stuff, we couldn't really get that information until it was already in the digester at certain times. So anyway, we think there was kind of this upsetting event that happened in this time period here. And the main point is the SENTRY, based on our judgment, showed us this upset several days before the traditional metrics gave us a warning. And if you've ever operated an anaerobic digester, several day warning is just could be the difference between losing a digester or not. And in fact, we went through 2 or 3 of these events for the pilot, and the first 2 times I think we lost the digester because to be candid, the SENTRY was new to us, and we were like, well, it's showing something different, but we didn't know what it means.
but also you guys were almost intentionally trying to crash that system in the sense that you wanted to find a high-end blend.
Exactly. But then the next time around, we were super focused on like, well, as soon as the SENTRY showed a deviation, we were like, oh wow, let's see what else is going on, and so the last couple of times we were able to stop the feed in time or increase the mixing or make other changes that ended up not having to dump an entire digester on the pilot scale.
And what was that kind of, did you guys settle on a blend percentage that you think is most appropriate at this stage based on that, or do you have a feel for that?
The main question was, can we go over 30%? Because again, there were these industry studies, I think it was LA County Sanitation or others had done it, says, well, anytime you go over 30%, bad things happen. So for sure, we went up to 60, 70%. Now, the nuance of that is, what is that 60, 70% made out of? Because we have 3 different things. We have fog, fats, oils, and greases. We have solid food waste that I showed you earlier, and then we have this engineered slurry. So, there are some nuances. We do not feel that comfortable going to 70% with fog, for example, because the fog is just very, we have no control over where it comes from, what's in the truck that day. But the two food wastes, for example, they're much more stable. In fact, so that's a great segue here. After the pilot, we ended up installing the SENTRYs in the full-scale digesters in the mixing lines. And this shows basically this year from September back to April, and on the full-scale digester. And so you can kind of, if you're just looking at pattern, you're looking at three different sort of operating regimes. On the left here, a lot of up and down, pretty big band. In the center, lower absolute numbers, very small volatility. And then on the right, something kind of in between. So what that correlates to is the left-hand side. That's what was our business as usual. We had 2 digesters. We were taking the 3 different feedstocks. So that was engineered slurry, solid food waste, and about 4 to 6 trucks of fog a day. And the fog was fairly random. It could have come from McDonald's one day to a brewery, not a brewery, but some different restaurants. So you can see that in a high degree of volatility in the data. Then we had, and this was not planned, we had a failure in the membrane, the Evoqua membrane cover that you saw on the earlier pictures ripped apart. So we had to take one digester out of service right there at the end of July. And out of an abundance of caution, we said, well, no more fog, no more engineered slurry, just wastewater solids and the solid food waste, because we had been taking that for almost 10 years. We're very comfortable with it. It comes from right down the road. We can inspect their process and the like. So that middle section there, July through August, is very calm.
Remarkably stable. Whatever that waste stream you're getting, that engineered food slurry, it is remarkably consistent.
Yeah, exactly. Yeah, so that's the non-engineered slurry. That's just the we call it pre-processed, and it comes as a cake. 20% solids. Basically, again, from whole restaurants that are just throwing away a whole bunch of stuff that's gone bad and the like. So, and it's not much. It's 6 tons a day, which is pretty small amount. So, but yes, very stable. And then we kind of said, because power costs are very high, like I said, and the bills were starting to pile up, and we were running our cogen engine below capacity, and the digesters appeared to be really healthy. So we said, okay, well, let's take 1 truck, I think it was every 3 days, of the engineered slurry in addition. So at the end of August, we started layering in the second stream, and you can see it's not as volatile as before, but it's definitely more activity and a little bit more volatility than when we didn't take it.
Exactly. And then I think, and this is just to bring it up, I pulled this up from yesterday. So
this is hot off the press. Yeah, exactly.
Yeah.
That's Tuesday 21st. So what we decided is, because the engineered slurry was working well, digesters are happy and healthy, let's take 1 truck a day of fog as well. So we just started that last week. And I think it took a couple of days, because it's only 5,000 gallons into a 1 million gallon tank. So it just takes some time to work itself into the signal and into the tank. But yeah, the last 2-3 days, we saw a significant change in the SENTRY signal. And so, this is actually subject of a lot of discussion right now. It's like, hey, do we want to maybe not take so much fog, because we're still down on a single digester. And again, we cannot afford to have that single digester go down at all.
Fantastic.
So I think, yeah, this one.
That was one other event. Yeah, we pulled that up. I just looked at, I thought that was interesting.
Yeah, that was an interesting one. I think if I was going to just make the final point, if we go back 2 slides to this one, the main sort of epiphany for me was, if we looked at our traditional digestive health metrics, which is mainly volatile acids, alkalinity and like. And just because of the size of organization, the cost of sampling, staffing, and timing, we can only get sort of one sample a day, and some weekends even zero. If you had looked at those on this graph, it would be basically a flat line, and it would have shown us that there's no difference on these different feeding regimes. But because we have this much more, like Chris said earlier, real-time data now, we're actually kind of realizing that digesters are acting very differently depending on how we feed it, and just having so much more detailed information, it's just really nice to have.
Fantastic. And then the one I'll just wrap it up with, Peter, on that is how we tie it back to the SOPs. And I think this is where we're at together maybe at this stage, is we have data and we know it's valuable and we know it tells us change and we understand those things, but what does that actually mean for the operator, and what does the operator actually do when he gets an alarm, he or she gets an alarm? So that's where we're at now with you is, okay, well, it's a high-end alarm or it's a low-end alarm. What do I actually do based on that information? And that's where we're, I think, trying to figure it out right now based on our SOP guide.
That's exactly right.
Fantastic. Okay. Peter, thank you very much. That's remarkable. Thanks very much. Chris, also, thank you very much. The reason I was so excited to get both of you guys on here together is because your paths are very similar in terms of not just saying, yes, give me a sensor, I'm going to put it in my full scale digester and we're going to believe you and we're going to do everything you say. It was kind of the opposite. It was like, yeah, give me your sensor and we're going to test it for 12 months in a pilot scale system and make sure it works. And then, we'll ease into this and we'll start, understanding decisions or making decisions on it more slowly, but just really happy that it's, we've come along that path. Okay, so I'll try and wrap some of this up in terms of, if people are looking to learn more about SENTRY or learn more about where to get SENTRY, we do have a network of manufacturers representatives across North America and Europe. So if any of these reps mean anything to you, then you can reach out to them directly. If they don't, you can reach out to me or Alex or Juliana directly here on the call. And with that, Alex,
Okay,
you want to take it away? Oh, we've one more question.
Yeah, it's a full time.
Sorry. Okay, sorry, the
It's
second
okay.
poll before we go to questions. Okay, thanks, Selena. What is the biggest issue you find in the optimal operation of an AD reactor? Okay, so what issues are people finding? So changing incoming loading, is that the issue you're looking to solve? Impacted by toxicity in the wastewater? Your biogas production is variable, or you just don't have any reliable data that's pointing you to upset or biomass type issues. If people can put their comments in there, and I think after that, once the comments are in, Alex, maybe you'll step up and coordinate some Q&A if there's questions coming in. Fantastic.
Let's see the result.
Oh yeah, okay, so changing incoming load, that makes a lot of sense, perfect. And then clearly that's leading to variable biogas production. So being able to understand the load coming into your plant better and link that to biogas production and understand the cause and effect, that makes a lot of sense. Toxicity, again, being lower, that also makes sense. Most wastewater streams are actually perfectly appropriate for anaerobic digestion. It's not that it's acutely toxic. It's not that there's these magical chemicals in it that are causing upset. It's a lot of the time it's overloading, organic overloading, because people just don't know what's in it or the load of that waste stream. Okay, thank you very much, Selena. Alex, do you want to coordinate some Q&A?
Sure. I don't see any questions coming in from the participants yet, but we'll give them a chance to formulate those and either type them in the chat or use the Q&A function. So in the meantime, I'll ask it if anyone was on the webinar last week or the week before, you'll recognize this question because it's my favorite one. But I guess, so for our two panelists, when you first put the SENTRY in, obviously you had some idea of what information or data you were going to get back, knowing kind of how it works and what the goal was. but what was the thing that surprised you most, either that you found out about your process or like a correlation that you weren't expecting with the SENTRY data? Just something that really surprised you about the process of putting the SENTRY in and then starting to get data back, any sort of aha moments that you weren't anticipating?
For Peter?
Yeah, I think that's a great question. And it's, for me, it's kind of it's sort of like, we're really in the dark ages before this, when you're getting this kind of one data point a day maybe, and it usually doesn't change much, and you kind of get lulled into the sense of like, hey, everything's fine. But when you do look at the SENTRY thing, and you just kind of see like under the hood, there's a lot of stuff happening at certain times, certainly in the digester, and sort of, I think it just helps shorten the focus on it might be all fine, but being extra watchful not to overload or get too far on the curve of risk on things, because it really does look like these bugs are cycling up and down every day, and if you kind of do a couple of days of pushing them too much in one direction, that may be enough of throwing the whole digester off stability. So yeah.
Fantastic. Chris, do you want to? Yeah, Chris, good man.
So fun things. First of all, like, so easy to install. Like we said, oh, put in a sanitary and screw it in and make sure it's pointing the right direction. That's great. I love that we put it in and it's churning out the data. It's giving us all this information, and I have not really had to think about it since we put it in. My science guys keep commenting it like it's doing everything it's supposed to do still, and I know for sure if it ever needs attention, maintenance, or anything, it's going to tell me right away.
Yeah.
Right. That's one of the greatest things, is that in my world, again, usually by the time you notice something, so much has already been lost. This is right away going to say, oh, right. I love simple.
Yes.
Right?
Good. So do I.
Yeah, and back to just to make another point too, what we're trying to do here, using poultry manure and farm digesters, everybody says you can put 20% in there, you're safe, right? Because anything more and it gets wild, because you're only reactive, and we're watching for biological crash. Ammonia is the monster that kills all of our bugs. Anything above 20%, chicken manure makes 8 times as much energy as cow manure. So if we can get a stable system using a really reliable feedstock that increases biogas production by 8 times in these facilities, we've moved the floor from very low, we're moving it from 20 to anything above. So from an economic point of view, it's tremendous. And again, a very small investment in SENTRY opens the door to potentially doubling, even tripling our reliability and our gas production. Like
Absolutely fantastic. Yeah.
I don't want Patrick to get an idea to start charging. I want to just buy a lot, but
we'll have to put you on a flow-based
something. Right.
So another question, I guess, just to build on what Chris was talking about with the maintenance, not something we touched on a lot in the presentation, but maybe just to speak to, that's definitely one of the issues that people face when dealing with sensors in a wastewater environment is fouling. It's things getting stuck on the sensors. It's trying to clean optical based sensors so that they work. So how have you found the maintenance now that you've had the sensors for a fair bit of time in different types of loading situations? How has the maintenance been?
We can even make it more specific, Chris and Peter. So we normally tell people visually inspect the sensor every 3 months. So you should take it out and look at it and visually inspect it. But most of our clients, when it's in real world applications, they actually install them and set it and forget it. And I think a lot of them never actually do the visual inspection. Could you guys maybe speak to, generally speaking, how often is it normally before you physically remove a sensor for any type of inspection, or is it just always in the wastewater?
Yeah, I think we're about 6 months in ourselves, and we took them out now for the first time, but for a different reason. Again, like I said, if I probably, and you might discipline me for this, but I probably wouldn't touch it unless it told me I needed to.
Yeah.
Or if you really shook your finger at me.
No, that's okay. Peter, anything? I
think the same thing. We you know, we look at the signal, and if something's weird in the signal, I mean, it's either is something wrong with the digester, or you know, is there something stuck on the sensor? But you know, we do have a lot of rags and contamination in our system, so I mean, it does happen. It is just, you know, something sticking in the flow, but it's not a big deal to kind of get it removed and deal with it. Yeah.
Fantastic. Okay, Alex, I think we're running up against the end of the clock here.
We are indeed. So I'll give one quick 20 seconds if anyone from the audience does have a question that they'd like addressed. They can speak now or message us directly if they don't want to ask it in front of everyone. So they can reach out to us. So Patrick, maybe you just want to mention how they can get a hold of us if they're interested in doing a more specific intro call to talk about how the sensor might actually address a specific problem that they're facing.
So
or if
who's
they
on
have any
there,
more.
take a screen grab of the page there. You can send me an email, send me a call, and reach out. And if anyone, myself or Alex or Julian on the call here. So yeah, if you'd want to learn more about SENTRY and getting a sensor in your system, then send us a note. Perfect. Chris and Peter, thank you very much. This was super cool.
Thank you so much.
Thank you.
Talk soon, folks.